Hello everybody and welcome to Alex Does LeetCode. Hi, I see someone in the audience. Welcome to the channel. First of all, Happy New Year to everyone. Welcome to 2024, and let's hope that we have a very productive year where we can learn about Python programming together. So today we're going to do a fairly short session, but I've also been toying with a new idea. Hi there, Chien. I've also been toying with a new idea, and I want to know what people think about it, which is so right now I'm solving these individual LeetCode problems, and every other week I'm also doing a programming contest. I'm thinking of doing a new type of stream, which is to write an application from scratch. I'm trying this out for the first time this Thursday, and I will be creating a Chrome plugin from scratch. I've never done it before, so I want to figure out how to do it together with all of you on stream, or whoever is going to be on stream, and all of you who are watching live the VOD afterwards. So let me know if this is something that people find interesting, or can still stick to LeetCode programming problems. At the end of the day, the most important thing is that you learn how to become a better programmer. That's the one thing we can all agree on. Alright, now on to today's problem. Today's problem is 3-sum. Let me just give me a second. I want to bring up. Oh, nope. Let's get my stream on the other channel, but it's okay. Today's problem is going to be 3-sum. This is actually a very classic problem. The more common variant and the simpler variant of this is 2-sum. And we're going to learn how to do this together. So let's start by reading the question. It says here, given an integer array nums, return all triplets, nums I, nums j, and nums k, such that I not same as j, not same as k, which means they are 3 different numbers. Well, they're from 3 different positions in the list. They could be all 3 could be the same number. Note that the solution must not contain identical triplets. So here's an example. You have let's say nums is -1, 0, 1, 2, -1, and -4. Then the answer will be -1, -1, 2, and -1, 0, 1. So these will be 2 triplets. Oops. These will be 2 triplets whose sum add up to 0. Now in this example, 0, 1, 1, there are no possible triplets whose sum add up to 0. So the answer is empty. And with 0, 0, 0, this is also pretty obvious. Now, there are a few things to take note here. The first one is, if you look at this example, -1, 0, -1. Okay? There are 2 -1s. There are 2 -1s. You can have one triplet use both of them. But -1, 0, let me see if I can undo this a little bit. But let me get a highlighter. Yeah. So this blue triplet is not different from this green triplet. Okay, the green triplet with -1, 0, -1, and blue triplet with -1, 0, -1, 0 and 1. Even though they use a different -1, they use a different -1, they're considered the same triplet. So that's what it means. Oops. This is what it means when they say your solution set does not contain duplicate triplets. The other thing to note is that even though there's a 0 here, if there's only 1 0, you cannot use it more than once. That's what this part means. I not the same as j, not the same as k. Okay. So anybody has any idea how to go about doing this? Anybody has the idea how to start? Want to write in the chat? Well, one way to think about it is Well, let's exhaustively check every single triplet, right? We're going to check every single triplet. So how do we do that? Well, we have a bunch of nested for loops. So you can say for I in range, let's get the length of number of the size of a list and call it n. We say for I in range n, and then for j in range, and we have to be very careful here. We might think it's range n again, but no, we don't want it to be range n. We want j to be larger than I. So we'll start from I plus 1, and it goes all the way to n. And the reason for that is we want to make sure we're using distinct. We want to make sure we're using distinct numbers. Don't want to use the same numbers, and we don't want to have I and j swap positions. And finally, k in range j plus 1 n. Okay, and then what we do is we have count equals 0. We say if nums I plus nums j plus nums k equals to 0, then count plus equals to 1. So we're counting the number of triplets. So this will generate all the triplets for us, and then we're counting the number of triplets whose sum add up to 0. And we see 1, they will increase the count by 1 and return count. So this would almost work. This will almost work. It will not give you the right answer. I'm going to show you why in a bit. But let's run it first. So when we run it, oh, sorry. You're supposed to return them instead of returning the count. So let's fix that. Let's fix that real quick. Okay, and now we run it, and I think this should almost work. I'll show you guys what I mean by almost work. Okay, it works for 2. Okay, this is not what I meant. This is not what I meant by almost works. Okay, it almost works in that it finds all the solutions, but it doesn't deal with the duplicate triplets. It doesn't deal with the duplicate triplets very well. Yeah, it doesn't deal with them because now you have different ordering of this. So this -1 0 1 comes from 1 -1 0 1, and this 0 1 -1 comes from here 0 1 and -1. So it doesn't deal with these duplicates very well. So we'll do something about this. So what we could do is we could say nums equals sorted nums. And then this is step 1. So we make sure that we don't reorder the triplets, right? We don't have different ordering of same triplets. The second thing we want to do is we want to check okay, so if we do nums equals or sorted, what this does is that we guarantee that all the duplicate triplets are of the same of the same order. So we don't get 0 1 -1 1 0 -1, we just get -1 0 -1. So these are all sorted in order. Okay, the second thing that we do is that we guarantee that duplicate triplets occur one after another. So when we add a new triplet, all we have to do is to check, aha, did I appear in the one just before me? Did I appear in triplets -1? Check if. So what we do is we add a check here. Not equals to triplets -1. And so triplets minus 1, this syntax means take the last element of the triplets list. And then if this is not same as last element, return triplets. If triplets also check if it's empty, if this is the first one, if triplets length for triplets equals 0, or, and this should fix the problem that we have. Okay, so this fixes the duplicate problem. And so we're pretty much almost done with this problem. Let me just, how do I make the font a little bit smaller? Let's do this. Okay. Close enough. So we submit this. Now there might be another problem here. You might be using global static variables or C++. Invalid syntax. Oh, it doesn't like that I added a space. Damn it. Okay, so this works. Let's submit this to see if it works. So there's actually one more problem, which is a little bit more subtle, that I want to talk about. Okay, and let me see what's gone wrong here. -2, -2. Oh, interesting. -2, -2, 4, -2, -0, 2. I see. So I can't just check the last one. I can't just check the last one. I have to check the whole thing, which is fine. That's interesting. So it's possible it ran, but when you submitted it, it didn't. Yeah, because when you press the submit button, it uses a lot more test cases. It runs a lot more test cases. So when I click the run button, it only runs 3 test cases. It works for those 3. But when I click submit, it runs like 312 test cases. And I passed 308 of them. There are 4. Well, 1 failed, and then the other 3 didn't run because this one failed. Okay, so this is the error that I was expecting. This is the time limit exceeded error. This means that look at this. Look at this input. Look at this. Come on, guys and girls. Look at this. This is huge. Let's think about what's happening here. Well, you see, what's happening here is that we have 3 for loops, right? So how long do we take? Now we're given a list that is extremely huge. This is insanely huge. Look at this. I don't even know how huge this is. This list. It's a super big number. Okay? So how long does our program take to run? Well, it has 3 nested loops. So this I goes from 0 to whatever n is, which is like let's say 1000. Okay? It's probably like 3000. It probably uses the max. So this is I from 1 to 0 to 1 to 3000. This is j from 1 to 3000. This is k from 1 to 3000. So how many times does it run? Well, 3000 times 3000 is going to run 3000 times 3000 times 3000 equals to 9. What is this? Trillion. It's going to run 9 trillion times, this for loop. And then it's going to do this 9 trillion times. That's very, very slow. That's like super slow. And so there's no surprise that we actually ran out of steam at the end. And not only that, you look at this, look at what's happening here. It says here, if not nums ijk in triplets, triplets.append nums ijk. Yeah, this kind of sucks too, because this means that before you add a new triplet, you have to go through all the existing triplets again. So this is potentially up to the length of the answer, right? It may not be 3000, but it's like some big number too. So how do you improve this? How do you make a better version of this? Well, let's try making a better version of this. So one thing we can do, let's think about what's happening here, right? We have 3 numbers. We want them to add up to 0. Well, one thing we could do is say, let's pick 2 numbers first. Let's say -1 and 0. Okay? And then we want to say, from the list, from the remaining thing, pick a third number. Does a third number exist? Okay, this is going to be our strategy. We're going to pick 2 numbers first. And then from the third thing, we're going to check if a third number exists somewhere else in the rest of the list that will allow us to complete this pattern. So the way we could do this is we can actually use a hash table. We can actually use a hash table. And then what we'll do is we will essentially use let's see. We'll use a for loop as before. But instead of doing a third for loop, what we do is we still need third number. So what we do is we take third number equals to 0 minus nums I minus nums j. Okay, so if I and j is -1 and 0, the third number needed to complete. So let's say I is -1 and j is 0. Then the third number needed to complete this pattern is 1. So third will be 1. And then we want to check. We want to check if third is inside the list. Okay, so we're gonna do it pretty much the same way. And the other thing we need to do is make sure third is, if third is smaller than nums j, we're gonna sort it again. We're gonna use triplets also. If third is smaller than nums j, then we want to continue, because we only want to output arrays which are sorted in ascending order, or at least non-decreasing order. So it's first, second, third. Okay, so Yeah, I think this should work. Okay, so what else are we going to do? We are also going to... Next, we're going to need some kind of dictionary. We're going to need some kind of set. We're going to say all nums. This is basically a set version of all nums. So a set, what it does a few things. One is a set is basically a version of the list that has no duplicates. It removes all the duplicates. And the second thing that's special about a set is that it's sorted. So it has some magic in it to make it so that when you look for, you want to check whether something is in a set, it takes very little time. Fast. Okay. So if third, I think it contains, or I think it's in. Okay. So this means that based on my first two numbers, third is not found in my list of numbers. So this means I continue. And then the last thing I need to do is, yeah, to then check oh, if it's not in the triplets, the set of existing triplets, then we append it. And I think this should work. Argument of type is not iterable. Third. Oh, oops. Let's run it first to see if it works. K is not defined. It's not num K, it's third. So the same thing here. Open was never closed. Okay, fix the little errors. -422. Ah, I see. So now we have a different problem, which is it's trying to use the same number multiple times when it's not allowed. Okay. So for this, one thing we can do is we can let's think about it. Well, one thing we could do is we can use a dictionary. We can use a dictionary instead of a set. Yeah, we can use a dictionary instead of a set. for third. Yeah, we can use dictionary instead of set for third. And the dictionary and put nums into dictionary. Num in nums. Nums num equals so we can just add, we can say all nums num. Okay, so this will count how many times. Okay, I and j is guaranteed to be fine. So we need to check if third is okay. We'll check it here. So we know this is in all nums, and we want to check that if third equals I and third equals j, then we want to check that all nums third is smaller or equals smaller than 3. Continue. Else, if third equals all nums so if if third equals I and third equals j, means all 3 numbers are the same. Two numbers are the same. Okay, then we want to check that is at least 2. We want to check that it has at least 2 things. Let's run it and see what happens. Wrong answer. It's getting rid of -1, -1, 2. But somehow this doesn't work. Okay, you know what? Let's put this into Python tutor and see what we can. Or we can put it in, let's put it in Replit. Let's put it into Replit. And let's see, let's debug this a little bit. I'm stumped just as much as everyone else is. I'm actually a little bit surprised that this doesn't work. I thought it would be fairly straightforward. Okay, so let's start by doing this. Let's put a breakpoint here and see what happens. And then we put another breakpoint here. Yeah. Oh, whoops. This is just something that we need to do. Because of the way LeetCode works, it uses a different version. The way LeetCode works is that it uses a slightly different version of Python. Okay, so we're here. Let's look at what happens to our dictionary. Our dictionary looks correct. -4 is 1. -1 is 2. 2 is 1. Yeah, so this should be this should be right. Okay, let's run it and see what happens here. So we're here. I and J. Third is 5. Oh, we need to go to here. Okay, we're here. Let's see. So I and J are 0 and 5, which is 0. This is I. 1, 2, 3, 4, 5. J is -4. Okay. And third is 2. Let's give us more debugging information here. Let's run this again. Okay, so n1 is -4, n2 is 2, and then third is 2. This is the one that we're looking at, right? Oh, I see. I see what the problem is now. It's not I and J, it's nums I and nums J. Or if we want, actually we should just copy this over. Make it a little bit easier. Pretty confident this will work. Okay, it's still too slow. Still too slow. I think this is the problem. This nums third in triplet. I think this is the one that's causing us problems. Are we guaranteed not to have a duplicate? I think we're guaranteed not to have a duplicate. I think we don't actually need this. We don't actually need this check. Let's submit again. Okay, so we do need this check. Okay, I think we don't need this check. If we do something here, if let me see. So okay, let's see. This is what I'm thinking about. Okay, if I is here and J is here, this works. But when I is here and J is here, we don't want this. We don't want this to happen. Because J will be, we'll get the same J twice. So we'll skip the j's. Skip the j's if we have done it before. Okay. Cool. If n2 equals to j minus 1, and n2 and j is larger than I plus 1. Continue. I think this will work. Okay, I think this will work. So minus 1 minus 1. So there are 2 minus 1s. I see. So I need to have the same check for here. Okay, so this should work, I think. Okay, so this works. I'm pretty sure there's an easier way to do this, but I have to think about it for a little bit. There's probably an easier way to write this, but I think this is a fairly efficient solution. Yeah, and that's it for today. Thanks a lot for tuning in to the stream, and see you next time. Next time, we're actually going to do a live coding challenge and see how that goes. All right, bye-bye.